Chapter 6 Gas-Powered Cycles, Internal Combustion Engines, ICE. There are 4 subchapters in Chapter 6. Subchapter 6.1 The Overview of Reciprocating Engine. Subchapter 6.2 Auto Cycle, the Ideal Cycle for Spark Ignition Engines. Subchapter 6.3 Diesel Cycle, the Ideal Cycle for Combustion Ignition Engines. And lastly, Subchapter 6.4 Dual Combustion Cycle. By the end of this chapter, please ensure you are able to evaluate the performance of gas power cycles for which the working fluids remain as gas throughout the entire cycle. And you are able to solve problem based on the auto cycle, diesel cycle, and dual combustion cycle. In the internal combustion engine, ICE, the combustion of fuel takes place inside an engine's cylinder. The engine cylinder is a confined space, and sometimes it is referred as a combustion chamber. Internal combustion engines are usually found in transportation. It also been used in several other applications such as the electrical generator. Similar to gas turbines, internal combustion engines in an actual application does not undergo a complete cycle, where there is no particular process to return the working fluid to its initial state. For the analysis purposes, the air standard cycle assumptions must be taken into consideration. The air is considered to be continuously circulates in a closed loop. Throughout the processes, the air is assumed always behave as an ideal gas. Also, the processes that make up the cycle will be assumed as internally reversible processes. In other words, it will be assumed as ideal process, and instead of combustion process, it will now be replaced by a heat addition process from an external source. One of the common internal combustion engines construction can be represented by this diagram. Cylinder, piston, intake valve, and exhaust valve. The internal diameter of the cylinder is called bore, and it is approximately equivalent with the diameter of the piston. Top dead center TDC is the maximum or furthest point of a piston can travel. At this position, it forms the smallest volume inside the cylinder. While bottom dead center BDC is the lowest point that the piston will reach. Also, bottom dead center is the point where the piston of an engine is the nearest to the axis of the crankshaft. At this point, it forms the highest volume inside the cylinder. Movement of the piston from the bottom dead center to the top dead center or vice versa is called stroke. Intake valve will be used to supply the fresh air or mixture between the air and fuel. An exhaust valve will function to exhaust or reject the combustion product leaving the cylinder. For the displacement volume, it is actually the displaced volume between the top dead center and the bottom dead center. Meanwhile, the clearance volume is the volume where the piston cannot travel. It will be the minimum volume inside the cylinder. For the compression ratio, RV, it is defined by the ratio between the maximum volume represented by the volume when the piston is at the bottom dead center, to the minimum volume that is represented by the volume when the piston is at top dead center. For the mean effective pressure, MEP, it is a fictitious pressure that, if it operated during the entire power stroke, will produce the same amount of net work as the actual cycle. The mean effective pressure, MEP, can be formulated as MEP is equal to work net out divided with maximum volume minus minimum volume. This expression can be used to find the mean effective pressure by using the specific properties. We can also have another expression for MEP with respect to the compression ratio, RV.